Hi, in this video we're going to look at answering question 6 of the Core 2 Practice Paper 1. I've made this video for AQA, but it's suitable for other exam boards too. If you need any more information, contact me on Twitter. Okay, let's have a look at question 6 then. It's asking us to find the first 4 terms in ascending powers of x of the binomial expansion, where a is a constant. Give each term in its simplest form. Okay, let's have a go then. Let's set this out in the same way that we would do always. So we've got 1 plus ax to the 7. So let's make a start. So we've got 7c0, 1 to the power 7, ax to the power 0. Notice that what I'm doing is I'm splitting these up. This one has the biggest power first. The second part, all in brackets, all to the power 0. Remembering that these numbers here relate to these. 7c0 I can find on my calculator. 7 and the 0, the numbers here always add to this power and should always be the same as the number at the top of this one. Okay, let's keep going for the next one. Plus 7c1, 1 to the power 6, ax to the power 1, plus 7c2, 1 to the power 5, ax squared, plus 7c3, 1 to the power 4, ax cubed. Is there any more that it's asking for? No, I think that's the last one. Okay, in which case let's start to work out some of these values then. Right, 7c0 on my calculator gives me the value 1, as does this. 1 to the power 7 is also 1. Ax to the power of 0 is also 1. So this whole first term is 1. Plus 7c1 gives me 7, multiplied by 1 to the power 6, which is still 7. Then I've got ax all to the power 1, so 7ax. Plus, on my calculator, 7c2 gives me the value of 21. So I've now got 21. And then we need to be particularly careful at this part here. Ax all squared isn't just ax squared, it's a squared x squared. And the same on the next part as well. 7c3 on my calculator is 35, a cubed x cubed. Okay, so I've done all the first bits, I've done the first 4 terms, giving the answer in its simplest form. Done. Let's also look now at part B, calculate the possible values of a, and that's for the x squared part. So what we know is 21a squared, x squared, is equal to 525. So we can work out what a is now, divide both sides by 21, so a squared is 25, square root both sides, a is plus or minus 5. Again, second part done. Not too many difficulties there at all. Okay, let's look at the next part then. Okay, part C is very similar to what we've just been doing in part A and part B. We're looking at the same sort of thing. It's a 1 minus, and instead of ax, we've got a minus 5 in this case. It's still to the power 7. So we can binomially expand this and then integrate each term separately. And that's fine, because we've done most of this already. Remembering from our previous part that what we had was 1 plus, so in fact what we're going to get is the integral of 1 plus, and then we had 7ax plus 21 a squared x squared plus 35 a cubed x cubed. Now we haven't done the rest of them, but you'll remember from doing binomial that you've got 4 terms here. The next 4 terms in this expansion are just going to be the same coefficients, but the powers are going to change slightly too. So we've then got plus another 35 a to the 4 x to the 4 plus 21 a to the 5, x to the 5, plus 7, a to the 6, x to the 6, plus my final term is a to the 7, x to the 7, all with respect to x. Okay. Now we know that a is minus 5. In this case, we've worked out the expansion before. We just need to change a now to be minus 5 in each place that we see an a. So we've got 1 plus, now I'm going to do it like this, I think, minus 35x. I'll keep all these bits in brackets and we'll see why in a minute. Plus we've got 21, so minus 5 squared is 25x squared, plus 35, and minus 5 cubed is minus 125x cubed, plus 35, minus 5 to the 4 is 625 x to the 4, and the next one, a to the 5, I'm going to have 21 lots of minus 3125 x to the 5, and then plus 7 lots of 15625 x to the 6, finally plus minus 78125 x to the 7, all with respect to x. Okay, now you can see that some of these are positive and some are negative terms, and it's much better to keep them tidy in brackets like this as you go, so that when you do your final step, getting all your coefficients together, you'll see you've got this nice sort of fluctuating pattern, but also that you've not made any mistakes anywhere. So the final thing that we're going to do is write it out neatly. So 1 minus 35x plus, and then we've got 525x squared, and then we've got minus 4375x cubed plus 21875x to the 4 minus, where are we up to, 65625x to the 5 plus 109375x to the 6 minus 78125x to the 7 with respect to x. And then for each term we can work out, we can integrate each term as we would do normally. Now we're not going to get very nice numbers, but it doesn't really matter. So we've got x plus 35 over 2x squared plus 525 over 3x cubed minus 4375 x to the 4 over 4 plus 21875 x to the 5 over 5 minus 65625 x to the 6 over 6 plus 109375 x to the 7 over 7 minus my last term 78125 x to the 8 over 8. Now I could tidy this up a little bit more, but to be honest, for 4 marks I think we've done enough work already, so we'll stop there. The numbers are nasty, the numbers are big, but the process is the same. And to be honest, I wanted you to do this question so you can go through the process rather than necessarily worrying about the numerical values too much. Okay, so when we're doing these final things then on binomial expansion, make sure you're only doing as much as the question asks. Don't do the whole thing if it doesn't ask you to. Take care with coefficients, especially when it's negatives, and use brackets. You'll find it so much easier to do. And finally, if you're not quite sure what you're being asked to do, as with this question, it didn't seem like we know how to integrate 1 minus 5 x all to the 7, but actually the binomial expansion part was leading us towards that. So if you're not sure, have a go at doing something and it might become apparent later. Similarly with part B, it might not have been obvious what we were trying to do in terms of equating the coefficients there, but as soon as we started, it made perfect sense. Okay, hopefully this has been useful and good luck with the rest of the paper. Bye.